Hi, I'm Nick Pelly. I'm a software engineer and technical lead working in Android Auto and Google Maps.
I'm Gabriel Peal, and I'm a software engineer on the Android Auto team. Hi, everyone. I'm Andy Brenner. I'm the product manager of Android Auto. And we're really happy to have you here today to talk a lot about the technical details and how you as developers can start to program your app for Android Auto. I've always been completely passionate about cars and gadgets, and so much so about a year and a half ago, I ripped my stereo out of my car and I put a Nexus 7 tablet in it. And this is before I got to Google. I put a video of it on the internet and somehow wound its way to Google, and about 2 months later, I found myself at Google in Android as a product manager working on this super secret, awesome product that we came out with today, or yesterday. So just want to go through some of the challenges we had when we looked at the problem space. Both cars and phones are these essential devices to everyone's lives. Oops. So when we look at phones, smartphones, they really contain everything about our lives today. They contain our contacts. They contain where we're going. They contain our next appointments. They have our music. They know our preferences. And because they're connected to the cloud, these preferences follow us around, even if we're on different devices or if we're on the web using a computer. So we love the connectedness of these devices. Similarly, cars are essential for our daily lives. They take us to our errands. They take our families on trips. We go on road trips and new adventures to find new places with them. And most importantly, they take us to work every day. So many people spend a lot of time each day in their car. Latest study was over 90 minutes a day average American spends in their car. Although they're essential, they're fundamentally disconnected right now from our mobile phones. So, drivers want to have those connected, compelling experiences in their car that they have with their phones, and so they take matters into their own hands. What do? They bring their phone into the car, and they look down at the phone when they should be looking at the road ahead of them while they're driving. And even though we all know it's relatively unsafe to be doing this, and we know in many states in the US and in many countries around the world it's illegal, people still continue to do it because phones and this connected experience is so compelling and essential. So those are some of the problems that we saw that drivers had. But we also saw that there were problems that developers had in trying to develop for the car. And I want to talk a little bit about some of those challenges that developers have if you want to actually develop for the car today. So first, there are many auto platforms out there. Usually each manufacturer, each brand, each model, and even model years have different software platforms. They have different APIs. They have different capabilities, which makes it literally a moving target for you as a developer. Secondly, there's also distribution difficulties. So if you're a developer, it's very difficult to get your app distributed to a car itself. And once it is on the car, it's actually very difficult to make sure your app is updated in the same way that you can on a mobile phone today. Moreover, there's safety regulations, and we're going to go into that in a couple minutes about what it actually means to do some of this testing you need to do in order to make sure things are meeting distraction guidelines, which are around the world and which many manufacturers also have their own guidelines of. If you're a developer, you actually have to spend a lot of time making sure that you meet all of these regulations. And I bet you guys want to be coding software instead of learning about the guidelines for driver distraction. And then finally, the compelling experience that people have on their mobile phones is that they're connected and they're personalized. And those are actually very difficult to do in the car right now. You have a key you put in the ignition, and sometimes that key knows, it's driver 1 or driver 2, and it moves the seat forward and backwards. But that's kind of the extent of personalization that's in the car right now. And so being able to have that connected experience where it knows everything about you and it's able to help you as you're driving is actually very, very difficult for apps to be able to harness right now. So what if it would be as easy as a developer to develop for the car as it is to develop for an Android smartphone today? Well, that's actually the solution that we worked on, and that's Android Auto.
Thanks, Andy. So what is the solution? Well, Google's actually been working in the automotive space for quite a while now. We first started partnering with auto manufacturers in 2005, and we've actually released Send to Car in 2007, Audi Earth in 2009, and Places API in 2010. These are all cloud-connected solutions. We're delivering geo-data direct from the cloud to internet-connected cars. These solutions are already on the road today. But we wanted more. So from about 2010, we started thinking very seriously about how to solve the problems that Andy mentioned. And the solution wasn't actually all that difficult. We knew the key ingredient was your smartphone. This was the piece that was missing. Android is a proven developer platform. As you saw in Sundar's keynote address yesterday, there are 1 billion active Android users at the moment. It's a pretty insane number. And I think most developers would agree this has been a successful development platform. Why does the smartphone work? Well, your smartphone is yours. It's got your apps, your services. It's personalized. If you look at Google now on your smartphone, it knows what your destination is likely to be. These are the kinds of solutions that we want in your car. We want your car to know you and know where you want to go to. Your phone also has a data plan. It has connectivity. So we want to bring the success of the smartphone to your car. The key here is we want to bring the success of the smartphone to the car in a way that gets around the life cycle challenge of the car. You keep your phone for 2 years, but people expect to keep their car for around 10 years. You don't want your apps to not work on a 10-year-old car. But as an application developer, it would be extremely challenging to try and compile, maintain, distribute your app to every single car that had been released in the 10 years. So, if the smartphone's so clever and the car's so challenging, then why connect to the car at all? Well, it's because your car has some awesome hardware. It's got high-fidelity audio. You've got surround sound speakers throughout the cabin. There's directional speakers that can deliver notifications straight to the driver. You've got directional array microphones to pick up your voice, even amongst road noise. You've got GPS and high-quality GPS antennas. You can't fit the sort of GPS antenna that you have in a car in a 5-inch smartphone. Wheel speed that was measured directly off of the actual rotation of the drive shaft, and compass, so you can actually navigate inside tunnels, which you can't do as accurately on a phone. On a phone, you have an accelerometer, but you have to integrate the acceleration in order to get speed, and it's very noisy. You're much better off taking the wheel speed directly from the car. Cars these days have a 6-inch display in most new cars coming out today, and the display is intelligently positioned so that you can keep your eyes on the road at the same time as glancing at the display. Cars are also designed specifically for being able to interact with them, being able to use input. Some of them have touch screens, some of them have controllers. The controllers are placed in just the right location so that you can just quickly, toggle the rotary while still looking at the road and keeping a hand on the wheel. Cars also have a giant battery that'll make any smartphone pretty jealous. So wouldn't it be a shame if we couldn't bring all of this great hardware from the car to your phone? So we knew the solution was to combine the best of your phone with the best of your car. What we didn't know is what the right architecture is to support this. There's actually a few different ways you can combine the phone and the car. So we started prototyping, and I'm going to introduce to you a little bit of our development process here. We started with an internal prototype called NavStep. On the left is a phone, the phone that you have in your pocket and you bring into your car. On the right is the tablet that, in this case, is emulating a head unit. We're just prototyping here. So we didn't have a real head unit during these prototypes. We just used a tablet to pretend to be one. In the NavStep demo, we're running Google Maps on the phone and just sending navigation data across to the car. It was just turn-by-turn instructions. We were using Bluetooth. I come from a Bluetooth background, so that was really easy to bring up. And we're actually taking those turn-by-turn instructions and then rendering them on the tablet. Pretty crudely in this case, I've just got a text dumped onto the screen. we were just developing at this stage. The key here is you have a mix of the application stack. You have Google Maps running on the phone, connected to Google in the cloud, sending low-level data to the car that is then has some of the application stack doing the rendering and the compositing and everything else. So this solved some of the challenges that Andy was talking about because we can now take advantage of Google services really easily. Google Now destination suggestions can be sent from the phone to the car very easily with this type of architecture. But we weren't solving all of the challenges because some of the application stack is still on the car, which means that as an application developer, you still need to consider how to get half of your application to cars that have been on the road for many years. The next step in our prototyping was Navcast. This is quite different. We're now sending compressed display and audio data from the phone to the car. Again, the car is the tablet in this prototype. So we're running Google Maps again, and you can see in the top right of the tablet, just faintly there's a Google Maps image that we're actually sending across that was rendered by the phone. Now, the key challenge here is low latency. It has to feel like you're interacting with a local system, even though the application stack, rendering, compositing, is happening on the phone. All those touch events are getting sent from the tablet to the phone, and we have to do that round trip as fast as possible to make latency work. So we worked very hard at this. It wasn't easy. We had to make changes to the Android operating system in order to do fast off-screen rendering, fast rendering into an off-screen buffer that we could then hardware compress and put over USB. We're using USB in this demo because we needed the higher throughput. So we got to a point through this prototyping where I was convinced that actually we could produce a workable solution here. The latency, I really love it, and I think if you go and look at the sandbox cars and watch our demos, this is a very, very workable solution. Now, the cast architecture, it's a real turning point because now we can move all of the application stack onto the phone. So you have that Android platform that you're using. You don't have to think so much about trying to get your application code onto the car. So we're able to scale this and put dial-up, music, and more applications onto the phone. And we hope to have more of your applications on the phone now too. So this was the beginning, really, of Android Auto as we know it today. If you're a podcast app, you can now write for Android, distribute in the same Android APK that you're using today, and see it appear on the phone. And you can upgrade via Google Play. You don't have to worry about how to distribute your application to cars that have been on the road for a while. You can just distribute them to the mobile device. The last stage of our development was, of course, to partner with car manufacturers and to actually get real head unit integrations of Android Auto. So that was the high-level architecture. Let's go into a little bit more detail about what this means for developers. Now, as I mentioned, the connection is via USB. I actually come from a wireless background. I've worked many years in Bluetooth and NFC, but USB is the right choice for our version 1 integrations because you charge the phone at the same time as you're running Android Auto. If you look at the protocol, now the protocol is transport agnostic. It's designed specifically. What we do is we map the low-level hardware in the car onto the protocol. We enumerate all the wide variety of hardware that you have in the car onto the protocol. I've just shown the general categories here of audio, display, sensors, and input, but within each of these categories, there's so many, audio, you have media audio, you have cabin audio for the driver. With sensors, you have wheel speed, GPS, compass. With input, you have all sorts of different controller types. The Android Auto protocol knows about all of this diverse hardware and maps it directly onto the protocol. We also have display and audio focus concepts. So look, this is really important because we can support use cases such as using the native interface in the car to select an FM radio station, play FM radio. You can then switch to Android Auto, go to Google Maps, pick a destination suggested by Google Now. All the while, you're still hearing FM radio in the background, but you'll then get turn-by-turn instructions from Google Maps that'll come over the car speakers, and it will duck the FM radio as the turn-by-turn instructions come through. Even better, if you then go to a podcast app on the phone, you'll then hear the FM radio will stop playing because we're negotiating audio focus over the protocol. So, if I go forwards now to what's happening on the car, you'll notice that there was not any application state on the protocol. We're focusing on hardware on the protocol. So we have a small library in the car called the Android Auto Receiver Library. It's a protocol stack. It's a set of interfaces to the hardware. It allows automakers to consistently integrate car hardware with Android Auto. We have Honda, Hyundai, GM, and Audi all here today with integrations of Android Auto. And we're working with many other manufacturers in the background to bring Android Auto to all new cars on the road. So, looking at the phone, the other end of the protocol stack is in a component called Car Service. Car Service is distributed in Google Play Services. It also uses some of the platform enhancements we put into the L developer preview to support fast off-screen rendering. Now, for developers, what you're going to notice is that we don't directly map the hardware in the protocol into APIs on the phone. There's a really good reason for this. It's driver distraction. It just doesn't make sense to support some use cases, such as YouTube videos or gaming, on the car head unit. Now, you guys are all great developers, and I'm sure you think you can come up with UI that is super slick and safe in the car, but trust me, you don't want to have to prove it. We've got a user experience research team that works on this topic, and they deal with pages and pages, thousands of regulations and from across the world that define things like minimum font size, contrast ratio, maximum task completion time. You don't want to become legal experts in all this stuff. You also don't want to have to buy a pair of occlusion glasses. We've got a pair here today as well that Gabriel's going to demonstrate. As cool as they look, they're not, you don't want to have to buy one of these every time you release your app. Now, what the occlusion glasses do is they actually block your vision and then open it up for 1.5 second increments to test that you can operate the user interface with quick glances. So look, we deal with the pixel pushing and we deal with the occlusion glasses for you. The diversity of car hardware is also challenging for developers, especially with car input. Some cars have touchscreens, some have controllers. When they're controllers, sometimes it's a 4-way, sometimes it's an 8-way, sometimes it's an 8-way rotary controller. Some cars have 8-way rotary with a touchpad on top that's separate from the touchscreen in the car. And some cars have that same controller repeated in the backseat, where the backseat controller sometimes controls the primary display and sometimes controls the backseat display. We handle all of this in Car Service for you. So what do we provide? Well, we provide templates and a common UX framework, and we provide semantic APIs so that you can work within the UX framework that we've provided. So look, really briefly, here's an overview. I'm going to actually go to a live demo with Gabriel to walk you through the UX in a bit more detail. So we're running on the tablet at the moment, the same tablet that I showed in prototyping. It's an easy development tool. It operates the same way that your head unit would operate. So at the top right, you'll see, we have common visual affordances that are in predictable locations. There will always be a microphone at the top right. If you press the microphone, you bring up the Google panel where you can have voice interactions. If we close this, on the top left, you'll see that there's an app menu drawer. This is always in the top left, and it opens up the app menu where we have a list-based navigation. Lists make sense in the car because you can operate them with touch. They have large touch targets, and you can easily operate them with controllers. Closing that, so we also have heads-up notifications. You heard about those yesterday in the L developer preview. Gabriel's going to trigger one. There it is. So Google Music just changed songs and showed a heads-up notification. Applications can customize content in the heads-up notifications. There's also the overview page. This is your landing page when you first connect Android Auto. You can populate content into the overview page as an application. So we have a solution and we have an architecture. And we have a UX framework that we think is much safer to use than trying to use your phone in the car. With that, I'd like to take it to Gabriel to tell you more about the APIs.
Cool. Thanks, Nick. So now that you've seen an overview of what Android Auto looks like and how it works, I'm going to give you guys a sneak peek of the Android Auto SDK. But actually, I can do one better than that. I'm going to give you guys a sneak peek of how you can extend media and messaging APIs to work not only with Android Auto, but also with Android Wear. A big theme of Android at Google I/O this year is that we're expanding Android to a lot of new platforms and form factors. It's coming to TVs and watches, in addition to phones, tablets, and cars. So, while expanding Android to all of these new platforms, we gave ourselves a real opportunity to make developing for Android a real nightmare. This is a real thing that we could have done, but we worked together closely with all the different teams to unify these APIs. So with both the media and messaging APIs I'm going to talk about today, you'll get native support for Android Auto and Android Wear for free. So the first thing I want to talk about is media apps. In media apps, we found this to be a particularly interesting space for the car. It's a crucial part of the in-car experience, and we knew that we had to get it right. Users listen to lots of different kinds of media, both on their phone and in their car, and we wanted to make sure that they had a seamless transition between the two. We think we found a balance that both minimizes driver distraction and enables a wide variety of media apps to feel right at home in Android Auto. At the same time, media apps can still maintain their brand identity and bring the custom features that makes their app special into the car. So what we've created is a semantic media API. By implementing that API, you can future-proof your apps and make sure that they support all Android devices across platforms as soon as they come out. One thing I want to note, though, is that in Google Play Music, we're using the exact same APIs that we're opening up to the public, so that your third-party media applications are actually first-party citizens on Android Auto. Let me just say that one more time. Third-party media apps are first-party citizens on Android Auto, and we're using the exact same APIs you guys will. So let me guys give you a demo and see what it looks like, and then we'll dive into some code and take a look at how you can implement and wire up your apps today. So if I open up media, the first screen that you're presented with is the media playback screen. On the media playback screen, you'll see familiar user interface elements from other media apps like album art, song titles, subtitles, that could be album art or anything like that, as well as some familiar controls like play, pause, forward, and next. I'll talk about how you can choose and customize those in your app later. But we know that the standard media controls aren't enough to handle the wide variety of media apps we want to feel right at home with Android Auto. So you can even add your own custom actions with custom icons that bring the special functionality of your app into Android Auto. Right here, we're looking at the Joyride app. In Joyride, on the primary screen here, you can see that they've replaced the previous button with one that skips ahead by 30 seconds, because that makes more sense for their app. They have more actions than can fit on the first screen, and if we open the overflow panel, you'll see that they have some additional actions, and there they have the previous action as well. If you want to switch between different media apps, tap the media icon in the activity bar again, and you're presented with a list of all of the media apps that have implemented the semantic API that I'm going to talk about today. If we switch to Spotify, you'll see that the UI is familiar and consistent across the different apps. But at the same time, they can customize their own branding so that the blue branding in Joyride has been replaced with a green one in Spotify. They also have custom actions now. So here they have actions to shuffle and add things to a play queue, as well as start a radio station and other things like that. If I open up the app drawer, you can see that, again, their branding continues here, and the scrim on the right side of the app drawer is green, so that no matter where you are in the app, the user will instantly look over, and they can just glance, and they'll know exactly which media app they're in, and they won't mistake yours for anyone else's. All the app's menus live here in the drawer. It's fully customizable by the app, and you can see here Spotify has Your Music, Radio, and Browse. They've even chosen to include a few custom icons so that you can quickly glance over and look and find exactly what you want. If we go into the Playlists menu, you'll see that menu items even expand to fit 2 lines of text if necessary. So you really get a lot of flexibility here. So that's what media apps look like on Android Auto. Actually, though, I can only show you so much on this Nexus 7 tablet today. If you actually use this in a car, we integrate your media apps into the car beyond what I can show you on this tablet. In-dash and steering wheel media controls will control your media. Your media metadata will also be shown directly on the instrument cluster display. And if the user temporarily switches out of Android Auto and into the native head unit software, your apps will still continue to play and be controlled by the same in-dash and steering wheel controls. So let's take a look at the architecture and what this thing looks like under the hood. I do want to note, though, that these APIs are still being finalized, and we're still making sure that we get this right. So some of the details of the actual code snippets might change a little bit between now and release. But we don't think the high-level architecture will, so you can start thinking about how you can prepare and get your media apps ready to support Android Auto today. The center of communication in Android Auto is in media service. Note, though, that I'm using the word service. When Android Auto is running, we put your phone in a special car dock mode. When your phone is in car dock mode, we won't launch any new activities on your phone. What that means is that all of the communication between Android and your app must occur through background services. You can indicate which service in your app implements this media service API by adding the iMediaService.bind category to your manifest. As we saw in the demo, when the user switches between media apps and Android Auto, they're presented with a list of all of the apps that have implemented this API. We'll take the app label from the application element of your manifest, and we'll also take the icon by default from there as well. But if you want to show a custom car icon, you can add metadata to your service with the name icon and a resource, and we'll show that icon instead. The initial handshake is pretty simple once the user launches your app in Android Auto. Android will bind to your service, and you return your implementation of media service. Soon after that, Android will call load app theme, and you can have the opportunity to get that customized branding and look and feel so that the user instantly recognizes it as your app. As you saw in Joyride with their blue theme and Spotify with their green, you'll have the opportunity to do the same and more as well. There are 4 primary things that you can customize in the theme in Android Auto. You can set a custom default background, so that if there's no active album art, we'll show that instead. You can also set a primary action color. Part of the material design across all these new Android platforms is a primary action that hovers above the main card on the screen. In our media app, that primary action is the play and pause button, and so the user can instantly glance over and immediately know how to touch and action on the primary action. If you set a primary action color, we'll tint the play and pause button with your app's primary color so that it's instantly recognizable. You can also set a panel color so that when the user goes to the overflow menu or opens the app drawer, we'll tint that menu or the app drawer scrim with that color as well. You can even set a custom color for the progress bar, so you really get a lot of flexibility here. Soon after you're requesting your app's theme, Android will request for a set of default transport controls. Transport controls are the default media actions that we found to be common across a variety of different kinds of media apps. It includes things like play and pause, next, and previous. You can set some default transport controls at the beginning when your app is launched, and they'll persist across different media items as the track changes and the user moves around within your app. You can change these at a later point, but if you want to set a default set of controls, this is how you do that. We do know that this isn't enough for a lot of the apps, though. As we saw in Joyride, they had a special skip ahead by 30 seconds action. Every time the media item changes, we'll call getAppActions, where you can return a list of custom actions that are specific to your app. An app action contains a description string, an icon, and a bundle. We'll take the description of the string and use that to populate the UI, and then we'll send the bundle back to you when it's actioned on. That bundle is completely transparent to Android. You simply send it to us, and we'll send it right back to you, so you know exactly what the user did when they tap on it. When tracks change, we'll call playEntry in your implementation of media service. We'll pass in the URI of the new track, and it's up to you guys to take action on it. A lot of the time, these actions and playing a new piece of media in a media app is done asynchronously. It might take network requests or various other things that take time. But we're not going to make any assumptions as to how your app works, and it's up to you to make sure that you update the UI appropriately. There are two parts of the UI that you have to update, the play state and the metadata, as you can see in the slide behind me. If you don't immediately know what the next track is, the UI won't change unless you actually do something. So if you're loading something from the network, for example, you can actually change the metadata to say loading and the play state to say buffering. But you want to act on this immediately so that the user has some sort of feedback for the actions that they take. So that's an overview of the high-level APIs of how you control the media playback screen in Android Auto. Let's talk about menus. So as we saw in Android Auto, all of the menus live inside of an app drawer, and they're completely customizable by the app. These menus consist of two main data types. They're media containers and media items. Media items are individual entities that can be played. It's actually the same data type that you use to update the metadata when we call playEntry. Media containers are lists that can contain other media containers or media items. And what you wind up with is a virtual file system of sorts. Media containers are like directories, media items are like individual files, and it gives you a lot of control over how you want the user to be able to browse through content in the car. Menus are a great way to browse content when the user can afford to take the time to look for what they want. Sometimes the user doesn't have that time, or it's dangerous to do in a car. So that's why we've provided an alternative that's even faster and easier to use than any menu hierarchy, and that's voice. Voice is integrated into every aspect of Android Auto. It's integrated into the platform. It's tied to your Google account, and it's tied to the Google Knowledge Graph. You can ask it almost anything. You can ask it to navigate somewhere, call somebody, text a friend. You can ask it questions that are connected to the Knowledge Graph, like what the weather is going to be like tomorrow. You can even ask it to set reminders, like remind me to buy milk when I get home, and it'll actually set a geofence around your home and remind you on your phone, car, and watch when you get there. It's pretty amazing. You can ask it to play media, too. If you say, play something with Google Play Music, it'll come right up. But we want to make sure that this is enabled for third-party media apps as well. In fact, there's actually been an Android action in the platform for quite some time. It's called Media Play from Search. If you implement this action in an activity today, and the user makes a voice search to play something with your app, Google Voice Search will launch your app and send it an intent where you can pull out the query and start playing that media item. But, like I said, we won't launch any new activities when Android Auto is running. And so all this communication has to happen in background services. That's why we've integrated this functionality directly into media service. When the user makes a voice query in Android Auto to play something with your media app, we'll call Media Play from Search inside of your implementation of media service, where you can then respond to that query, and then it's almost like any other play entry. That's an overview of all of the media APIs that we'll be releasing for Android Auto. When we began showing this to our pre-release partners, they were able to get it running in their existing apps in a matter of days. And it felt right at home in Android Auto. We're still working with them to make sure that we get you all the best possible tools so you can bring the best experience that you can to the car. We do know that you guys are working on apps beyond what we've imagined, though. So please, come talk to us. We want to hear what you have to say. Next up is messaging. Messaging is one of the most dangerous things that people do in a car. It leads to countless accidents every year. Part of the problem is that drivers have to take their eyes off the road in order to send a message. That's why we've created a 100% voice-driven interface so that the user doesn't have to take their eyes off the road in order to send a message. When a new message comes in, we'll display a heads-up notification, and Google Voice Search will read back the message to you. You can then reply to the message with voice as well. When we ship Android Auto, we'll have full support for SMS and Hangouts built in. But we know that people use other messaging apps, and we want to make sure that they have the same seamless experience with those apps in Android Auto. Once again, we've worked closely with the Android Wear team to make sure that you can build your apps once and have them just work across all these different platforms. So by building support for messaging apps into Android Auto, you'll also get support for Android Wear for free. At the core of this new API is remote input. Remote input is a new class that's part of the Android L developer preview we released today. It's also going to be in the latest version of the Android support library. You attach your remote input to a standard Android system notification action. In Android Auto, when we detect a messaging notification with a remote input, we'll use that to open up Google Voice Search to let you reply to a message with voice, and then we'll send the results of that back to your app with a pending intent. So there you have it. What we're offering with the first version of Android Auto is a rich set of media APIs that provides a consistent UI for the user, yet gives you guys the flexibility to maintain your app's branding and keep your custom features and make them accessible in the car. And a voice-driven messaging API that minimizes driver distraction and lets drivers send message without ever taking their eyes off the road. Because both these APIs will get you support for both Android Auto and Android Wear, there's never been a better time to develop for Android to allow your user experiences to travel with the user throughout their daily life across different devices and platforms. We're really excited to show you guys what we've been working on. We're going to have a lot more information in the coming months about the product and about the SDK and about opening up this for all of you guys to start working. To stay up to date, check out developer.android.com/auto or leave some comments on g.co/AndroidAutoDev, our Google Plus community. We'll be monitoring that and keeping track of what people are looking for in these APIs because we're really dedicated to make sure that you have the tools that you need to make a strong app for Android Auto. So I think we just have a few minutes left here. We'll answer a few questions you have now, but we're doing live demos on the third floor, and the three of us and the rest of the team will be up there all day if you want to come ask any more questions. So thanks. No questions? Okay.
So my question is, how's the integration with built-in stuff? For instance, I have a Leaf, which has a lot of electrical, all of that integration, energy consumption type of stuff. Does Android Auto integrate with that, or do we bump out of Android Auto to go to stock?
Yeah, it's actually interesting. I actually have a Leaf myself, so I'd love to see more integration with EV vehicles. We've actually been working with automakers and still under discussions with them as well as with you guys on how to bring what we call car data, which is things in terms of an EV, such as range, battery life, things of that nature, to the platform. It's actually a very complex issue because you have user privacy issues, you have manufacturer questions. We need to make a platform so that it's common across all the vehicles. So those are questions we're still working through right now, but we definitely want to open that up to you guys when we can. But it's going to require a lot of discussion that's still ongoing.
We do integrate car GPS and wheel speed already today.
Hi, I had a question about the media APIs, about audio. Does this use a specific media player, or can it just forward any audio using, for example, OpenSL to the car audio?
Yeah, so right now, just playing back over the system media stream would be sufficient, and it'll play through the car audio system.
Thanks.
Hi there. I was curious, is there just to be clear, is there anything we can do right now? Are we able to get that experience you had on the tablet on our own tablets so we can play around? Is there any APIs open right now or anything?
Yeah, it's a really good question. It's a combination. So with the remote input stuff with Android Wear, because it's part of the Android L platform release, you can check that out. You can look at the Android Wear documentation for more information on that. But we're going to have a lot more information in the coming months about getting an emulator. You're not actually going to need a car in order to develop apps for the car. We'll definitely be providing some sort of emulator or something so you can develop apps for the car right on your computer. But we're not actually releasing any of the SDKs today. But definitely stay tuned. We'll have a lot more information coming up.
Thank you.
You guys referenced briefly that users will be switching between the Google Auto and their native head unit software. What's that transfer going to be like from kind of a user interface experience perspective?
Yeah, that actually varies based on the manufacturer's implementation. It's up to the manufacturer to work on that transition because, as Nick mentioned, many cars have very different controls from each other. In some, it's a touch control. In others, it's button presses on the head unit. So it depends on the automaker. We have best practices that we work on the automaker with, but we want it to be as seamless as possible. And as Gabriel mentioned, if you start media, for example, in Android Auto and then switch out of Android Auto back to the native system, your audio will continue to play. We still have audio focus, it's called, even though the video might be on the native system.
So depending on the manufacturer, it could be either a touch button to switch or a hard key?
That's right.
Mm-hmm. Okay.
And it may also depend on what you were doing on the phone before you plugged in, for example. There's some context there. If you were navigating on Google Maps before you plugged in, it would make more sense to transfer straight into Android Auto. But if you had your phone screen off, maybe you just want to charge, and that's why you're plugging in. So there's some context there to help us decide as well.
Okay, thanks.
Yep.
So about the audio service type of thing, like obviously most players that want to play things in the background already have a service that's running that does that, and almost all of them use the remote control client to provide playback controls on the lock screen. So why the decision to make a totally separate bound service instead of reusing some of those components?
So we actually go far beyond what you can do with the remote control client today in Android. We want to bring as much of the app experience as we can in a safe way to the car, and it simply wasn't a large enough API. But we include things like menus and custom app actions and stuff like that you wouldn't get support for if we just use remote control client.
So the expectation is that we have one service that implements both the remote control client callbacks and these callbacks as well?
However you architect the app is up to each individual app, and it could depending on various implementation details. But the overall architecture, it will live in some sort of service inside of your app.
Hi, you guys kind of mentioned that the connectivity is through the USB docking, right?
Mm-hmm.
So,
yeah.
And when the phone connects, it transfers to the auto mode. Will there be any features on the phone get disabled at that time?
Yes, so as you can see, if you come for a demo on the third floor, we lock out the phone. The phone screen is blank. We put up I don't know if we can right now, but you see a logo on the screen. We lock out the controls. The system bar at the bottom and the status bar at the top are both locked out. We want you to look at the car screen. And we think we have a great experience for you when you do. That's more safe than looking down at your phone when you should be driving.
The colors are crazy.
So yes, that's what we have.
And then what happens to the Bluetooth interface? Today, all car manufacturers support the Bluetooth connectivity, right?
Yeah, so as part of plugging in your phone to the car, it varies on the manufacturer, but we generally will auto pair with the manufacturer's Bluetooth. We use Bluetooth for phone calls so that you can use your car's hang up and answer buttons on the steering wheel as well. So you'll actually have an enhanced Bluetooth experience with Android Auto compared with without Android Auto. So Bluetooth is used.
Thank you.
So with the fixed UI, how will it impact the traditional ways of the freemium apps, which are ad supported? There's no place to put an ad anymore.
So we don't think you should be looking at an ad on the screen. Kind of defeats the purpose of what we're trying to do. So we actually would not really support putting an ad on the screen while you're driving, But you can maybe do an audio ad, and we have some partners like Pandora that do have a freemium model that
Do you
will
have
show
any
you that.
information on whether your current partners are going to charge for the car feature?
That's up to the individual partners. You'd have to talk with them. They're using their same APKs that you would find in the Play Store, the same packages, and they're just enhancing them with this additional API set and service that we're talking about. So it's really up to the developer to decide how to distribute their app and what business model they want to use.
Thank you.
Yep.
So my question is, you guys mentioned a lot about like auto manufacturers implementing this Android Auto into their head units. What about custom head units? Talking like big name Pioneer, things like
Yeah.
that. Will we possibly see those sooner?
Well, so we're still, we have nothing to announce right now. Some of the companies you mentioned, like Pioneer, have joined the OAA, but we have no product announcements on that today.
Okay, thanks.
Any plans for introducing an SDK for location-based services, like navigation, for example?
Yeah, so that's something that we're not announcing today. We're focusing on media APIs and messaging because we see those as the first kind of primary actions that drivers want to do while driving that right now they use third-party apps for a ton. But we're looking at new use cases for the future, and that's why we'd love to have you join the Google Plus community that we had up on the screen. Might be still up on the screen there. So actually, if you go to that G Plus community or scan the QR code, we'd love to get your feedback as a developer on what new use cases we should support next.
Okay, thank you.
Yeah,
Sure.
or just come chat to us, actually, the third floor. We'd love to just hear
Yeah.
the exact use cases.
Totally.
It'll help us really figure out what the right APIs to open up next are.
Okay. Well, I mean, my question to that is basically focused in on navigation application outside North America and Europe. For example, in China, we don't have Google.
Yep. Yeah, those are certainly questions we're working through, and
Okay.
but we'd love as a developer to hear your feedback on those type of things.
Okay, good.
So please
Thank
come
you.
talk to us. Yeah.
Hey, hello. You guys mentioned car data like compass, GPS, speed. Will that be available to other applications via like a broadcast receiver or an antenna or something?
Yes, so GPS actually, we integrate with the Fuse location provider, if you know about that, on Android. So when we get GPS coming in, that goes into the FLP and is available to all apps using the FLP.
Great.
One thing that's important though to note, with FLP and with any other car data that we were to open up, it would have to follow the permissions model. So we're going to have new permissions if we have other types of car data. For location, you obviously have to have the location permission. That's very important for users because we want to make sure that if a user is downloading and installing your app, they opt in to allowing you to use their car data. So it's a fundamental part of Android that we're not changing.
Great. And one other thing to that, if the phone is plugged into and you become in auto mode, what happens to non-auto applications that maybe are running in the background, services? Are they killed? Are they allowed to let run?
Yeah, they still run in the background, but you can't launch activities, as Gabriel was saying. But they can still run background services.
Okay, great. Thank you guys.
Hi. So we're actually actively working on the where notifications. And what I don't understand is if you've got that going, will it translate over to auto, or do you just have to do auto to then translate to where?
Yeah, that's actually an interesting question. It's not only a technical question, it's also a user experience and product question. When you're walking around with your Wear device, we actually want you to get pretty much any notification that's appropriate for the user. But, so with Wear, a lot of notifications are not filtered out. But in auto, we do think it's very important that you only get notifications that are appropriate for the context of driving. So there's definitely going to have to be a curation process. It's a subset,
for
exactly.
sure. But the thing I'm wondering
From a technical perspective?
If we're developing right now for
Yeah.
where, and this auto stuff
Yep.
makes sense for a couple of the things we're already developing, like how quickly can we translate between the two, or can I combine that effort?
It should be trivial.
Trivial.
With the latest version of the Android Wear documentation, there's a new extension for notifications where you can extend them with Wear extenders, We may have a similar thing for a car extender, so you can add additional options to an existing notification, but it would be as simple as adding a few lines of code to some existing code that you already have.
And then timing-wise, so where stuff is available now, we're hoping to have that released, say, in August.
Yep.
And then auto stuff would come.
Stay tuned.
And we
Soon.
just flip it with a few lines of code is what you're
Yes,
saying?
pretty much.
Correct.
Okay, thanks.
I think we're about out of time. But if you have additional questions, please visit us on the third floor. We'd be more than happy to talk with you and as individually. Thanks a lot.